Okay, I'll introduce the panelists after hopefully a short introduction to the topic, and I'll introduce them as each one answers a question or addresses a question. So what I'm going to do is maybe a little different than what the other panels have done. I'm going to try to present a scenario of a scientific problem followed by how I'd like to interact with that problem. And then we'll look at where we are today and where we'll be in, say, 2030. The problem that I want to look at has to do with small-scale structure in the ocean, which is a problem that actually comes up or is a parameter or processes that come up in a lot of the small-scale or in situ observations that take place. One of the things about numerical models today, the large-scale ocean models that are designed to look at climate change generally are coupled with atmospheric models and operate at a very coarse scale, 50 to 100 kilometers, and then they're run for a long time. And at that scale, that means that each point in the model is representative of what's happening for that 50 or 100 kilometers. There has to be some way of characterizing the physics, the processes that happen at smaller scales, and that's the small-scale parameterization. And to get that right is absolutely critical in these models, as these models move energy from large scales to small scales back and forth. So I'm going to show you first, I'm going to try to show you, this is a satellite image from a recent sensor, VIIRS. It was launched about a year ago, year and a half, well, 2 years ago now. And it's a very high resolution center. And I'm going to focus on that area in the small black box. And what I'm going to do is I'm going to look at the magnitude of the sea surface temperature gradient in that box. And by the magnitude of the sea surface temperature gradient, I mean the temperature at one point minus the temperature at all the points, at any of the points around it, the largest one of those, and that's what I'm going to show. And I'm going to actually show the logarithm of that, because I don't want the plot to be overwhelmed, or the figure to be overwhelmed by the very large gradient associated with the Gulf Stream. And this is the image that I got when I did that. And I've probably looked at 100,000 satellite images in my career. And when I saw this one, I said, oh my God, the structure in this is phenomenal. This new sensor is amazing. You can see there's that red square, by the way, is about 100 kilometers, a little over 100 kilometers by 100 kilometers. So it's at that scale, or maybe a quarter of that scale, that the numerical models are trying to parameterize. They want to parameterize the physics that's at those smaller scales. And what you can see is there's a dramatic amount of stuff that's happening at smaller scales. Up until recently, it was assumed that the processes that were happening at those smaller scales, or the movement of the ocean at those smaller scales, was simply being advected by the larger scale motion. Now what we're finding is the processes at these smaller scales are actually critical to the flux of energy from the large scale to the small scale. And unless we get that right, our large scale models aren't going to work quite right. So it's critical that we get that right. This is a beautiful image, and actually the resolution, it doesn't look as nice on this screen as it does on my screen, but it's amazing. 2 days later, I have another image from the same area, and things have changed dramatically. The difficulty is that we really don't know what's going on beneath the surface. This is what's happening up at the very top of the ocean, top 10 micrometers in this case, but it's representative of something a bit deeper than that. So what we need to do is we want to understand the processes at deeper scales. So what I'd like to do is I'd like to get all the data I can at larger scales. So what I'd like you to do is to dream with me, or dream with us, about what a system would look like to do a study like that. So what I'd first do is initiate a dialogue with a colleague who may have data in that area. Charlie, do you have any data from that area? Not that area, I'm sorry. Charlie, do you have any data that might be appropriate for this problem? For example, data in an area where there's a lot of structure from one of your gliders.
Of course I do.
Oh, that wasn't a plant. Wait.
All I need is some funds to go get it.
So I'd like you to share the data with me. So I'm assuming that you're going to share the data with me. And what the dialogue then, I'd have a dialogue with Charlie that would proceed in the context, this is my vision now, the future, in the context of a fully 4D field, showing the data, and with the satellite data maybe at the top, Charlie's profile going through it. There might be some numerical model data. And I might want to move through this data, this virtual data sphere, if you like. I might want to grab data objects and ask questions about them. I might want to expand an area, and as I expand it, I would see finer and finer resolution. At any point in the process, the structure that I would see, what I would see in front of me would be about the right amount of data to not totally overwhelm me. So the data would aggregate and disaggregate with scales as I expand or contract. I'd be able to point to a time bar, expand the scale, move along, stop at a time. And I might see a problem with the data. Hey, Charlie, at this one point here, it looks like the density changes a little abruptly. Do you have any idea what the problem might be?
You may have a raw version of it. We may not have made a salinity correction properly here. So let's see if I can check that.
Great, thanks. So anyway,
is that what you
he's
wanted
checking
me to
it. Did you find out what was wrong?
Yeah, the satellite was wrong.
Okay, so I can experiment with subsets of the data. I can pull subsets of the data in. I can throw out certain data that might not be appropriate. I can move seamlessly from data discovery to analysis, back to discovery. At any time, I could plot up the data, and I could say, I want all the citations. I want citations for all the data objects that are in this plot. And my colleague, Charlie, would say, wow, he noticed something interesting there. I'd better note that. I hadn't seen that before. And it would go back into his repository. Well, the system is learning. The system is learning about the dialogue because this is all happening in the context of the system. So this would be a nice view. Well, this would be a cool view. It would be really neat to be able to do this. It doesn't scale very well. I know Charlie, actually, you guys never started the timer. So we're, oh yeah. Okay, now where was I?
He can dance. He can dance. Man can dance.
Right, so it doesn't scale right. It turns out I know Charlie because we bound on a cruise together. I remember I had to, he was on shift, or what do you call it when you're in a boat?
It's
he was on watch on the ship.
It's a watch, and it's a ship.
And I was asleep.
Okay.
And all of a sudden, I feel this thing squeezing my toe. The room's totally dark. I open my eyes, and there's this thing in front of me with these flashing red lights all over the head. And I said, oh, my God. But that was Charlie. So I know him. So I was able to go to him because I know him, so I could ask him. And there are other people that I might know in the audience as well. But there's a lot of data out there that from people whom I don't know. And I'd like to be able to look at different areas in the ocean, different structures, et cetera. So that it's not, knowing an individual isn't going to scale. So what my colleague and the data set curators that I queried, what I'd really like them to be is maybe HAL 9000, for those older of you who would know the movie.
You
Siri,
are dating yourself.
Siri, can somebody turn off his mic, please? Siri, Watson, OK, Google.
Wait a second, are we having a few too many Mai Tais?
OK, maybe I had too many Mai Tais last night. But back to reality. What I'd like to do, that's my vision of what the data world would be like. It could work in a virtual institution, as we just discussed. It could work for retrospective data, as I was talking about. Or it could work for real-time data. I could be sitting in the Interspace Center at the University of Rhode Island, looking at a glider or a vehicle, AUV, that's been put in the water by Falcor, and I could be looking at one of these structures. I have a satellite image. I say, whoa, look over there, and they would look there. That would be really cool. Is this vision complete? If not, what's missing? These are questions that I'd like the panel to address. How much of this vision is possible today? How much do we think will be possible in 2030? What are the obstacles to achieving the vision? And how might technology help us address these obstacles? So that's what I'd like the panel to take the next 32 minutes to talk about, and then we'll go to questions. So, panelists, any one of you, and we have not, this is not scripted at this point. Each one of the panelists can choose any question they want to address and address it. So, anybody have any questions? Or would like to address any of these questions? Sorry?
You want to introduce us?
Well, I was going to do that when you ask the question.
Okay.
So, would anybody like to address any of these questions? Dawn.
Sure, I'd like to start.
Okay, hang on a second. This is Dawn Wright. She's the chief scientist at ESRI, which is a GIS company, which if you know GIS, you've probably heard of ESRI. Go ahead, Dawn.
Okay, thank you, Peter. I'm also an affiliated faculty at Oregon State University, and I'd like to address the first question on is the vision complete, and if not, what is missing? And I'm really going to touch on more of a sociological, cultural issue, following on from the prior panel. Rather than get into the technical details, I'll let my esteemed colleagues handle that. But in the scenario that Peter just laid out, it struck me that there's so much that is needed in terms of how do you do all of those things that are required in that dialogue. How are you going to assimilate that data? How are you going to analyze it? How are you going to be able to build a system to do the kind of 4D visualization that's required? How are you going to understand the analysis of the results, and then how are you going to communicate that to your colleagues, especially if your colleagues are interdisciplinary? They may not be satellite oceanographers. They may be policymakers. They may be people who are interested in marine spatial planning. What does it take? What kinds of students should we be producing in order to participate in this kind of scenario? And it struck me, we've had so many good prior panel comments that we can build on in this panel. I was struck by Paul Falkowski's comment in the very first panel yesterday, where he talked about we kind of do data instrumentation on the side. And we kind of our students, our postdocs, pick this up from experience, and they do very well at it. But they are not formally trained in that kind of engineering, computer science. And it struck me that it's the same way with data. Our students, our postdocs, us, we sort of do data management, data assimilation, data visualization on the side. And Marcia has already pointed out that data interoperability is one of her goals. I think it was goal number 3, but she mentioned that that was the most important, and we very much appreciate that, Marcia. So if that is such an important goal, should we not be training our students in data issues, data management? That is missing in our curricula, and it's something that is completely doable. It's completely within our realm. The vision is not quite complete, though. It's missing, and I think easily remedied. And I think one of the things that we might consider is cultural change at our institutions. We train our students in biological, chemical, physical, geological, oceanography. We put them through those 4 core courses. Some of our oceanographic institutions do include ocean engineering, and it seems to me that this would be a good slot for ocean data management. The word informatics was used by Susan in the prior panel. That's a new field. Informatics is actually moving into the realm where scholars are being produced who are called data scientists. So I'd like to introduce that term as well. I think it was mentioned by Ajit briefly yesterday. We do have ocean data scientists who are in our ranks. Some of them go to sea. Most of them go to sea, Peter. But some of them don't. A very important cadre of our ocean data scientists do not go to sea. And as was mentioned at the end by the gentleman who was sitting next to Michael Jones also yesterday, that there's so many of these young scholars who are very, very eager to engage in ocean data to look at all of these different informatics issues. And so I would like to posit that we need to be training our students to be aware of these issues, to be rigorously competent in these issues. They should be ocean data scientists. And also the idea of a data scientist is not someone who is just an IT person. So I'd like to posit also that the IT people, it's not an us versus them kind of dynamic. And that the wonderful thing about data science is that these are domain scientists who are competent in these data issues. So these are people who have gone to sea, people who are skilled, have expertise in the physical, biological, physical, chemical, biological, geological, geophysical sciences of the oceans, and they're also working with the data as well. We have some wonderful examples of data scientists among us, and I think of people like Dave Caress, who's a geophysical oceanographer but wrote MB system, which has been so very important for our community. Paul Wessel with generic mapping tools. So maybe I'll stop there because I have taken up, I think, almost 6 minutes. So.
Yeah, that was an interesting take on it. Thank you very much. Would anybody else like to take a crack at it?
Sure, I'll take a crack at it.
Okay, this is James Gallagher. James Gallagher is Vice President for OPeNDAP and the Chief Technical something or other for it.
Yeah. Right, the something or other. Yeah. So I'm an engineer. That's my training, and OPeNDAP is a 4-person nonprofit corporation. So I also empty the trash can. And we're also a completely distributed organization, but that's not really what I'm going to talk about now. So I'd like to talk about how much of this is possible now, and touch on 2 different things in that. Relating to that. And the first is about open data and about how actually I got involved with data access and data access software. And so originally I was a graduate student and I asked Peter for some data, and he got sort of angry with me because it was a burden on him to give data out to people all the time. And what would happen is a student who is working in computer science would get data from him and then come back a week later asking how to read the data, and come back a couple of weeks later asking what it meant, and so on. And I'd sort of forgotten about this because it was a long time ago. And this morning I had a conversation with a gentleman from Texas A&M, who's right there, and he said exactly that. And so all the things that I planned on saying, I realized maybe were less important than this. That when we talk about open data, and the gentleman providing the glider information to Peter, that we need to, in order to make it so that people will freely give their data, to make it be open data, we need to make that a path of very little resistance. That is absolutely crucial. Another hard lesson I learned also from Peter is that when you build a data system, the system doesn't work if there's no data in it, okay? So if we want to have open data, we're going to have to get data in it, and if people like y'all are going to be providing that data, it has to be easy for you. You don't have the budget to hire your own team of programmers to massage data and build servers and all this stuff. So that I think is absolutely critical in open data. Now, I've heard a lot of conversations at this meeting so far about other characteristics of open data that are also important, and I suspect we'll get a bunch of questions about those. So I'm just going to leave that for you all to ask us. That way I don't have to talk for so long. I did also want to touch on Peter's notion. One of the statements he made, he was going to move seamlessly from discovery to access back and forth as he changed resolution. And one of the issues that we've come up against many, many times in building data access systems is a wall I was going to say dichotomy, but it's really a wall between searching for information and actually using the information that you've searched for. And I'm going to put forth that in a lot of ways, that wall is make-believe. That's sort of the emperor's new clothes. That, in fact, what you can do is that you can take a lot of that information that you, quote, need for searching, and you can move it into the part of the information store that actually holds the data. And then the process of accessing the data can actually be the same as the process for searching, as the process that is used to search for the data. And I'll give you a concrete example, and I hope it's not too weird. But so satellite data, lots and lots of satellite passes, and let's say that those satellite passes have been processed to a relatively high level, like what NASA would call level 2 or level 3 data. So each pixel in one of the images in the data set corresponds to the same latitude and longitude as you move from one image to the other. So you can take a series of two-dimensional image shots and put them together into a three-dimensional cube. Now, just keep that in your mind for a moment, so push that on the stack. Okay, going back, how do we typically think about looking for a particular image or group of images in a satellite data set? Well, first of all, you go to a directory that lists that's a catalog that lists lots of different satellite data sets. And when you find one that you're interested in, you go to an inventory, and that correlates dates and locations, but let's just say dates with specific satellite images. And you say, well, I want everything for the first 7 days in January 2012. So now you go and you get the 7 images. Well, if you do what I just said, if you take all of those images and you aggregate them into a higher dimension object, then you can subset that dimension not only in latitude and longitude, but also in time, and extract out a cube of data. And what you've done is you've taken the process of searching the inventory and you've turned it into the data access operation. And that is a way that you can take that basic concept, which I'm talking about, and it's fairly coarse because it doesn't work with a lot of data, but you can take that notion of aggregating data along the axes of the domain or the independent variables, and you can say, okay, we can extend that out, and we can make for seamless search to access. So I'm going to stop there because I talk way too long.
Okay, thanks a lot, James. Actually, James talked about satellite data, and I talked about satellite data. I understand that the focus here is primarily on in situ data. It is important to keep in mind that NASA has not been mentioned as a funding agency at all, and yet they're probably one of the biggest funding agencies for oceanography. It's just we don't think about it that way, but when it costs $1 billion to send up a satellite and it's only for oceanography, that's funding for oceanography. So we might want to keep that in mind. But anyway, that's an aside that had nothing to do with data access or whatever. Does anybody else want to take a crack at one of the questions?
Sure.
Whoa, so Matt, you want to
Sure.
take, okay, hang on a second.
Let's actually take the...
Wait a second. This is Matthew Arrott, and he's responsible for the vision behind the OOI cyber infrastructure and for implementing it. Is that correct?
Well, I'm going to correct you on that, not the vision. There are many people in this room. Larry Mayer actually headed up the cyber infrastructure committee that did the design and vision part of it. I, John, and a few others in the room were responsible for the architecture to try and meet that vision. What I actually like about the first 2 questions is there's a semantic problem with the first 2 questions. You used the word vision, and you didn't use the word capabilities, and you didn't use the word implemented. And what I would say is, at the time that we did the OOI in 2004 and 2005, it was an IT almost exclusive team. There were a few scientists on board, John Arrott, Larry Mayer, but both of them also represented significant experience in the engineering and software realm. The vision that was spoken about in that room, it had a very hard time being presented at the Salt Lake City conference. It was very hard for people to hear. But yesterday, from Marcia, from Susan, and a number of others, we've heard the vision now spoken as though it is a given. The virtual organization, the cloud. These are words we use without even thinking about what they mean anymore, whereas when we spoke about them in 2005, they were not words that were even there in our lexicon. So, participating at that time, I believe the cyber infrastructure team on the OOI had this vision. They got that vision from the virtual observatory from the astrophysics. So I believe the vision is fine and it's stable and it's growing. It's permeating across all of you. You actually know the vision. The next is, in this ensuing 7 years, industry has outstripped our ability to actually even keep up with the implementation. The cloud has flourished. High bandwidth access has flourished across the country. The notion of social networking, working in virtual organizations, working in virtual groups, has flourished. The real issue behind it is one of implementation to a target, and the second is the target is very hard to see, because ultimately what we're dealing is with a socio-technical problem. And you could hear it today in that when we talked about the virtual organization, I kept wanting to say, is that one or is that many? And there was a spectrum of choice if you listen to the language on the panel. I think Oscar, from my perspective, hit it correct. Virtual organizations are based on domains of interest, not on scientific, on the brick and mortar notion of institution. They're different, they're completely separate concepts. As soon as you go there, you then have to ask a separate question. What is the individual versus the community? Ultimately, all work pretty much gets done by the individual. Do you anticipate that the individual will be capitated or belong only to one virtual organization? If, in fact, they don't belong to one virtual organization, how does the individual conform this information to meet your vision of this four-dimensional ability to access data from anywhere in a way that is conformant to your perspective? And these are the real sociological challenges. The technical ability is there, but being able to marshal the resources and the focus to implement with a certain amount of exactitude to actually deliver on that vision, being responsible for the OI, I can say, is extremely difficult.
So a big obstacle is sociological. Is that the bottom line?
Correct.
I'd buy that. Anybody else want to take a crack at one of the questions? Okay, Brian Sullivan is the Google Oceans project manager. Did I get it right?
Project, doesn't matter.
Okay.
So I want to take a slightly different take on this. So you've outlined this beautiful mission and the vision, and in some ways it's kind of the Mission Impossible, James Bond, ocean exploration immersive experience. And so, I mean, it sounds like a great thing. I mean, who wouldn't want it? And let's say a mix of private industry, whether it be ESRI or Google or any of these other ones, or a government thing builds it, and we bring it to you and it serves up your petabytes of data and you can swim through it and everything else. The thing I'm worried about is after you put on the goggles and you say it's great, Peter, your first question to me is going to be, so I assume this runs my Fortran code, right? And I'm going to be honest with you, the answer is no, it doesn't, and it's not going to. And so I want to talk a little bit about maybe the piece of like what we think is possible today and what really is possible today. And actually, before that, there's one other question that came up with the idea of like systems. Is this one big system or is this lots of little ones? And I think this has come up again and again throughout the conference. It came up for boats, it came up for ROVs, and I think it comes up for data systems as well. I mean, the reality of it is we can design one massive system, and there'll be constraints on that because we'll want it to do everything. But I'm from the private sector, and my feeling is that we're going to go off and we're going to develop a smaller system that will do something, and it will do something today. And you guys will be doing similar things. And I think what matters is that we have that interoperability between them. And I think there's lots and lots of products that are coming out. So if you have your data in Google, you can easily bring it to ESRI and vice versa. And as more and more of these aggregators are coming out, it's moving data between them that's valuable. And so one of the things that a lot of people have approached me to, they said, I would love it if Google Oceans had habitat mapping for the Northeast coast, and I have that data. And someone else says, I really wish Google Oceans had sea surface temperature. And my life is now a lot easier because now I can give an answer that I couldn't give a year ago. It says, I agree with you, put it there. And so we now have an ability that anyone that has this type of GIS data, you can submit it to our repositories, and we'll make it easily searchable and discoverable. That's what Google does. And Esri's building out very similar things. And as we mentioned before, we're making it easy to kind of bring that data between the two of them. So think of it as kind of the YouTube for maps. So if you have a whole stack of cat videos or a whole bunch of dolphin videos or the other things, like you don't want to set up your own server for that. You don't want to index it. You want the world to discover it. If you put it in Google, we can search for it, and instead of returning a web page, we'll give you a map that's fully interactive, and you can work with on that. And so if you have data that you'd like to bring in, you can do that, and I'm happy to help with you. But you're going to do the heavy lifting on that, and I'll give you as many tools as possible to make that discoverable. And then I think there's another technology that we've come out with, and I'm not here to push a product or anything else. I just feel that this is something that a lot of people would be interested in if they knew it was out there. And so one of the luxuries of being in a private company that has a lot of cash in the bank is that we get to kind of say, I'm not worried about quarterly returns, I'm not worried about my next source of funding, so we can look longer term. And so we had a bunch of really smart people from NASA that said, okay, we're engineers here, we want to tackle global issues, and we're finding our data sets don't work for it. And so we've built out these analytical capabilities that we have taken the entire 30+ years of Landsat data, and it's all on disk. So everything you've described, you can do that in 1 or 2 lines, and you don't have to pull everything back up for it. And it was built with the idea of we wanted to do analysis, visualization, and everything else on top of that. And so some of the examples of that are we're doing deforestation quantification in the Amazon. And again, these are local researchers that have built out their own analytical capabilities, and they can run it for a small square in the Amazon, and maybe it takes 3 days to process. In Google, you can do that in basically real time because we'll parallelize the whole thing. And if you want to do it for the entire Amazon basin, you just need to zoom out. So if you could play the video real fast in the background. This is one example of a product that we've generated. So this is 30 years of Landsat data. Anywhere you go in the world, you can now visualize that change. And so this is a visual piece of it. And remember, there's all the scientific work behind that as well. And so the Exploratorium started to take some of this work and make it an interactive piece so people can really visualize this well. The size of the data for this, I think you have about 9 displays set up to visit that, so it covers a good piece of the wall. To fully show this, you need 900,000 displays in high def set up there. And so what does fast mean when you can do this in real time? It means you can swim through that data the way you described. This is Las Vegas sprawling here, Lake Mead's coming and going down at the bottom. So it means you can work with it in real time, which means you can actually start doing that exploration without a hypothesis and see what jumps out for you. It also means you can take on projects that you couldn't do before because you really want to do it at the global level. And so these are tools that are available, and we've built them for the research community. When we release these things, we've had commercial industry banging on our door with suitcases of money trying to get access to it, and we said, that's not our intent now. It may eventually become a commercial product, but it's for research now. And the metrics that our team uses for how effective we're being is how many publications in the scientific community are leveraging this. And I think there's a huge opportunity here for oceans to take advantage of these type of things. Things are a little bit different in oceans, but we don't need oceans tools. Like Google builds general platform tools, and we just want to put ocean data in there and let you guys loose on it. And so if you are interested in gridded data sets, we can do this at a very large scale. Vector, we're getting closer. I can't bring all the in situ sets in yet, but anything that's gridded, we can scale it up. That's not a problem at all. I mean, Landsat alone is just about a petabyte, and that's laughable for us. So if you have bathymetry that you want to bring in, we want to make that work for you. I mean, the sea surface temperature thing you did, I think, is incredible. But as soon as you do that local question, your next one is, well, where else does this occur, and where else in the world it is? And if you want to do that analysis for the rest of the world, scroll out, and you'll have it. And then that allows everyone else to kind of share that the same way. And so if you're interested in this, please come talk to me. And some people say, well, how come Google Oceans is only 3 people? And I think the way we grow that is I get to go to Google and I say, here's what the oceans community is doing with Google tools. And when we show examples of that, then I'm able to get more resources, and there's a lot more we can do then. So I hope I can talk to some of you about this.
Well, I will talk to you about,
And we will not run your 4chan. I'm telling you that right now.
about it's about, the data set I showed is about 1 petapixels a year, I think. And there are already 2 years of those data, and there will be 2 satellites in the not too distant future. So
just to comment on that, I think we can ingest that, but what I want to make sure is that there's a community that's going to use that.
I'll use it.
Okay. Go get about 15 of your friends, or maybe even 5 of them, and show us how you're going to use it, and then we'll work with you on that.
Okay, actually,
Just to
real quick, because
quick.
I'd like to get to John.
This is a very good example of the vector of integration from the underlying data all the way through the tools needed to manage the data, through the analytic processes that are applicable to that structure of data, out to the ability to deliver it to the end users and their own applications. If you could just put up the other slide. There are domains.
Oh, that's me.
And this is one of the fundamental, this is one of the fundamental issues that we are all going to face, and it is just as concerning as the semantic issue, is that the underlying structures of data come in very different forms. And this tool depends upon the fact that it is gridded. We have within oceanography a whole taxonomy of data structures. Each of them have their own set of operators. Even though those operators can be semantically called the same, they operate very differently because of simplifying assumptions over these structures. And so our challenge is to be able to grow this vector and to be able to use this vector, but also to break down the territorial boundaries between the different data structures.
Okay. Actually, in your video, if somebody wanted to know about a particular scene, a particular frame in a scene, is that all extractable? Is that available?
I mean, if you're interested in like the Landsat tag for that or anything else, I mean, not in the video you saw, but in the backend tool, yes, by all means. Right. And it's really meant so that anyone else can reproduce that in any other area, or kind of use that because it's a common data set shared across it.
So I think this is a perfect segue to John Graybeal. And John is the data manager for metadata and semantics at Marinexplore. And the reason I think the segue to him is good is in the vision that I presented, it was not only access to data, but access to knowledge about those data. And that is a critical part. I was able to ask Charlie because he's my buddy and he squeezed my toe a long time ago. And, well, maybe I shouldn't.
Thanks. Maybe we should move on.
So John is a metadata guy. So give us some of your metadata take on this, and I'll go back to the questions, I think.
Sure, yes. If we can go back to the questions slide, I have a somewhat radical approach, which is to actually try to answer the questions. And so in my experience working on metadata and oceanography for the last 10 years, and then more recently getting the opportunity with Marinexplore to actually attempt to put into play many of the principles and ideals that I talked about with great fun for the years before. I think it's clear to all of us in the room, but especially the 60 or so of us who are really immersed in the data management, that the vision we put up is nowhere near complete in the sense of the details, that there are dozens, hundreds of specific capabilities. Probably 5 of them came up in the previous panel: citations, publication credit, DOIs, persistent identifiers. There's a whole range of details like that. And it maybe is a little bit radical to say that an awful lot of this vision is possible today in actual operating systems. Some of the ones that were just mentioned being examples, Marinexplore being one that's coming. There are others I'd like to mention. R2R and BCO-DEMO are two examples that have applied a lot of these principles. MyOcean from the European community applies a lot of these principles. And Virtual Oceans is another. There's just a raft of capabilities that you start to see emerging. And they're going to continue to emerge and strengthen over coming years. I had the argument with Peter that we should not be talking about 2030 because I think 5 years from now, you're going to see a lot more capability. And by the sesquicentennial that Marcia brought up in the keynote, there's no doubt that a lot of this will be possible. It's not going to be possible pervasively in every system. They're not all going to be beautifully interoperable. There'll be all different levels. To get a feel of what it might be like in oceanography 10 years from now, type in weather in your zip code now and see what all the different services look like you can get for weather. Some of them really aren't so hot. And so you'll see different levels of capabilities and different services. The types of obstacles that exist right now in producing these services are not technical obstacles for the most part. They are, to some extent, cultural obstacles. I fully endorse Oscar's comments in the previous panel in this regard. There are issues of the reward system that he talked about a lot, and so I won't amplify. And I think the trickiest issue that we're starting to wrestle with fairly aggressively in Marinexplore is the issue of scaling of metadata access. If you have, it turns out metadata is complicated, it's messy, it's often not readily available. And if you want to get metadata for all the ocean assets that you're trying to import in a system like Google Oceans, Virtual Ocean, Threads, there are some protocols and standards that help you right now, but they aren't widely adopted throughout all the providers of ocean data. And so we have the combination of cultural and reward system changes that I think are inevitably going to start to overcome that as we go forward. So the final question was about how technology can help address these obstacles. And the answer is, of course, that a lot of it already is addressing these obstacles, both in the commercial applications and the available of open source systems, but also in the social changes that are coming from the Facebooks, LinkedIn's, Twitter, the whole social media universe is creating a change in how we feel about sharing about ourselves and about our data and about the importance of having access to other people's data and how easy it should be to find out something. And the latest release from Google Butterfly, I think is the code, or one of the names applied to it, is the newest search engine technology and question answering technology is the beginning of what Peter started us off with in the Mai Tai section of the talk, where are we going to get the Mai Tais in the actual, never mind, talk to you there. It is the beginning of actually being able to ask questions of your assistant or your computer or these systems that are out there and starting to get the answers back that are useful, that go all the way back to the original metadata that somebody supplied 8 years ago or 9 years ago, which would be like tomorrow, because they realize, hey, this is going to be important. And if I want to get my micropayment 10 years from now because somebody looked up my data set, I better say who it was that actually curated this data because they're going to care about that, possibly.
Thanks, John. I agree that most components of the system are doable. I think it goes back to Matthew's comment that it's putting them together that's the issue. And they're so sociological. The main barriers are sociological, I think. But okay, so we've run out of panel time. So now it's question time. So am I the chooser? Okay. Okay, got it. Go ahead, you're on.
Beth Orcutt from the Bigelow Lab. A lot of the conversation we've been having is about sharing data with one another as scientists or engineers. I think something that we need to be thinking about also when designing or figuring out how we're going to do this is also how do we engage citizen scientists who may be going out with their ROVs and collecting video or flying their drones over places and taking photos, and they want to interact with these Google Ocean resources or whatever else. And so I think we also need to be thinking not only about reward structures for ourselves as scientists and who's publishing my data, but also how do we engage other people that want to be involved in this, want to know what's going on with our ocean, want to contribute to what we know about our ocean. So I'd like to hear you talk about that.
I'll just be brief. Since I'm not a scientist, so I don't actually work in oceanography, but I do know something about some terrestrial ecology projects which are distributed and which involve a wide degree of participation. And one characteristic of the successful projects is that they specifically design their methodology so that it is easy for people to contribute to and participate in at a variety of levels. And one of the gentlemen, Georg Grabner from the Gloria project, said he designed his experimental procedure specifically so that it would be simple but scientifically valid. And I think that's very important. And actually, I think that has a lot to do with interoperability and making systems interoperable. But I'll stop there.
I think it's a great question, and one of the things that struck me with Brian's comments is that we are, from the industry standpoint, we have become very, very open in terms of directly engaging with citizen science groups, with community organizations, with K through 12. I mean, Google has done a wonderful job with this. At ESRI, we do the same thing. We're giving away software. We have an education team at ESRI that actually will work with citizen science groups and help them even develop curricula, develop modules, make stories with maps and so forth. And so I think this is endemic of a cultural change from industry standpoint as well, because we're talking about culture changing across the academic oceanographic science community, but with Google talking about how they are going to engage with researchers and not sell your technology to companies, to me that sounds like a very radical, forward-thinking concept. And at ESRI, we are trying to do the same thing where we are actually bringing scientists in for sabbaticals with us to develop technologies using our approaches, but also helping us to improve our approaches. We have just had a professor at Penn State who works on citizen science projects with us for about 6 months. And so this is all very important. We are breaking down not just the ivory tower, but the silicon tower as well. And there's a lot of good, friendly cooperation among industry. ESRI is a vector company, so we are working on all of the other data structures in Matthew's taxonomy for ocean science. We just had a summit about that in November, where we actually have software solutions now to work with finite element output, unstructured grids, point clouds, and so forth. But the idea is to trickle that down all the way to the general public level as well. So I think it's all good.
I just want to say that I was involved in citizen science early in my career when I was using satellite data, and one of the local fishermen from Cape Cod came up, and he said he would put a thermometer on the end of his fishing line and throw it out into the surf and give me the temperature if I'd give him the satellite images. So
Wow, what an opportunity.
it was very exciting. Go ahead, John.
Just wanted to add something that I haven't heard discussed so much previously, but was very exciting in the Marinexplore context, was the addition of challenges to the opportunity for the educational system, where they can participate in the analog to the right whale challenge that we did with Kaggle, where outsourcing this challenge to many hundreds of competitors, as it were, each working and collaborating or not on their own approaches, really advanced the state of the practice. And I think that's another opportunity in the educational sector.
Okay, does anybody have a mic? Go ahead, you're on.
Okay, first of all, I'd like to start off by saying that I fully support the idea of data sharing and release and data visualization.
You should probably identify yourself.
I'm Chris Sabine from PMEL. As Dave McKinney said earlier, we've been had a policy in our lab of releasing data since the early 80s. We've developed tools like Ferret and Live Access Server for visualizing and exploring data. So what I'd like to do is present some obstacles from your questions. And I have 3 quick case studies that perhaps the panel can think about and talk about how we might address them. These are all real things. So in the first case, I've got a graduate student that comes to me, wants to look at short-term variability in carbon cycle. So she works for months to put a CO2 system onto a mooring at Station Papa. She goes out to sea and deploys it and works very hard. She comes back at the end of the summer, goes back to her classes. Following summer, she's ready to start working up that data, and one of these data scientists that's sitting at their computer sees that there's this great new data set that's coming from the Papa mooring and contacts us and says, I've got a paper that I've just written on this, exactly what my graduate student was going to write on. What do I do? Second case.
How many cases do you have?
3. I have 3 quick cases.
Second
case.
Can you make it 2?
In my lab, I've got 200 moorings that we service a year. I'm busy writing proposals to try and keep all those moorings going. I get 10 inquiries from 10 different people looking at 10 different moorings saying, I see something odd on this. Can you look into it and help me what's going on? Just like you asked Charlie, I'm in the middle of writing my proposal. I can't get to that necessarily everyone right away. I get another message 3 days later saying, why are you holding me back from publishing this paper? Are you trying to stifle my ability to work with these data? Third quick case, someone takes that data, publishes it, and it just so happens that that one particular mooring, it ran out of a standard gas, showed a little jump that just happened to correspond with a time when there was a bloom. They write this whole beautiful paper about the CO2 signals that were corresponding with this bloom. It's all fake. It's all wrong because the CO2 system ran out of gas, and they never contacted me to find out about what might have been happening with the system that caused that jump.
Okay, so thank you. Matthew, sorry.
I believe what you have to do is look at how communities work. And there are different modes of what will you call sanctioning. Because in each of those cases, the norms for the community are all violated by those 3 cases. And so the question is, do you build in the system up front abilities to block such behaviors, or do you choose to build in mechanisms that are feedbacks that develop over time what are the appropriate responses to inappropriate behavior? And I think that if you take the approach of being in the loop, proactive, you are going to immediately stifle innovation.
I would just quickly comment that the vision of the system I had, I don't think that would be as much of a problem, because the information would all be there, instantly accessible, and it would be up to whoever the scientist is to look at that information and make use of it.
Yeah, the thing that's missing now is, in the first case especially, I think, is the identification of these entities as first-class members of the web, if you like, such that when someone says, I have a question about that thing, that data stream, that mooring, that whatever, they can go directly to the page for that data stream or mooring. They can see the comments that have been made before. If 10 people have called you up about that glitch, the last 9 see that the first one has and +1 it. This is the social approach to wrestling with that large-scale issue. It's not there yet in this community, but you can see these companies starting to put it into place.
Could I also add that this is, your use cases are perfect examples for training our young scientists, training our students. And it goes back to the point that I was making about the curriculum that's needed in ocean science. I think it was Leighton who mentioned the ethics surrounding data issues. You touched on a couple of ethical issues that we need to make our young scientists, well, I don't want to just give up on our senior scientists, but certainly the yeah.
School, it's okay.
But certainly our young generation, our emerging stars. There is curriculum that exists. There is a curriculum that Oregon State and Penn State and University of Minnesota has been working on in terms of the ethics of all kinds of data, where these kinds of use cases would be perfect, and these kinds of things can be plugged directly into an oceanography course.
I would also point out that the person that published without contacting me was in Europe. So
totally different norms there.
So there's the international cultures. It's different in Canada. I mean, there are important differences in our cultures: U.S., Canada, Europe, Australia, and so forth. So very important.
So who has the mic now?
Hello.
Where are you?
Leighton again. We keep on going back to it. It is a reoccurring thing. The change of thinking in the community, the fear in that question about publishing data, about getting it out of there, what people will see. Also, we deal with a lot of scientists who don't want to release that data. And as much as we're all clear thinking here, I've supported 70 science cruises, and getting it out there is quite worrying. Also, there's this single point. If we said about putting it all on a online resource, I know a lot of PIs who I've dealt with, some of you are here, who would be worried about the long-term availability of that data and what will happen to these organizations. For example, if we stopped using a certain map one and had to go over to, say, Apple's flat and bending maps of the world on our phone, how we deal with that. So the long life of this data, and also how do we change the culture? How do we, because there's a lot of people who simply won't share, and the data they have hidden away in their cupboards and in their safes is a lot of, will help us.
I just want to make one quick comment, and then I'll let the panel go after it. James started off his comment by saying that one of the reasons people don't share is that it's work to share. It's not that they want to essentially keep their data from other people. And I think that there's a myth in the community that most of us don't want to share our data because we want to keep it for ourselves. And I don't think that's true. But
you actually finished that because I believe the other day you provided a much better picture of a notion of reputation associated with the data, and that there is a quality control issue,
right,
that when the data goes out, that data is associated with you. And so therefore, there is a desire for it to be perfect. And we heard this about the instrumentation. The developer of the instrumentation does not want to release it for other use, not because they are trying to actually gain profit. They're as much concerned about its use and the reputation that accrues back to them that they can't control.
right. Brian.
So I think there's a couple examples there. So the first one is, how do you get people to share data, especially in these aggregate methods? And so one of the things that we're doing when we ingest bathymetry data now is we're correcting all the datums across the board. And so if people can analyze, if we have global grids that have one of the richest sources of bathymetry, and you want to compare your data to everyone else, well, as soon as you give it to us, your data is actually more valuable to you because we've corrected it against everything else. And the case where maybe there's some new buoy data out there, it's not so much that you care exactly what the reading on that particular buoy is. You want to compare that area to everything else. And the way you compare your data to the rest of the world, when the rest of the world's data is really big, is you put it in the cloud where other people have access to it as well. So now you contributing your data gives you value as well as giving everyone else value. So that's kind of one way of feeding that system.
Okay.
But we're correcting some, like the NOAA data, but not all of it, because our partners are correct.
Sure. I mean, it's a general principle of that.
Okay. Who else has a mic?
Okay, so Jules Jaffe.
Yeah.
I'm going to make a moderately orthogonal statement, which you can choose to ignore.
Okay. Next question.
Yeah, right. So 40 years ago, when I got my degree in information science, it wasn't even computer science, and we played with a program called ELIZA with Joseph Weizenbaum. It figured out, we had all this interactive, and there was a big debate about how smart computers might be. And so here we are in 2013, and I think they're pretty stupid still. And so I think we need to raise the bar. And so my comment is, when are we going to start getting semantics into this process? And so, I had this vision at one time that I would sit down at my computer, say, "Good morning, Dr. Jaffe, how are you today?" what do you want to talk about? What would you like to study? Well, maybe I'm you and I'm interested in mesoscale eddies in the South Pacific, and I could say to the computer, hey, do me a favor and go out there, and who did that, 20 years ago? Who's doing that now? And are there any new data sets around that would allow me to learn more about what that's going on? So my comment is that, we're still in the Stone Age here. We're talking about picking out points in 3 dimensions and space. And when are we going to transition into actually getting meaning so that, we can tell how to open the pod door?
So the vision that I laid out actually started off almost exactly like that.
Okay, sorry if I missed
No, that's okay. And that's why I said in the end, we have to go to Siri or whatever. But is anybody else? Not Siri.
I think
HAL
that
9000,
John is
sorry.
John and others, but John in particular
John,
is the
go
real
ahead.
authority on this. But I saw a very good illustration of the complexity of the problem of semantics the other day. And I watched John struggle with the semantic effort for over a decade now. The issue that I saw expressed in just one graph was, if you can get to a place where my vocabulary for dog maps your vocabulary for dog, is where we're working. The real issue is, what are my associations to dog with your associations for dog? Because I may think of fur and bones, you may think of friend, companion to my father. And so there are very, very hard mapping problem. The virtual organizations, if you think of them correctly as spaces of conformance, or what I call ontological commitments, you are choosing to go into a space where a community has worked out a canonical model, and you map into that. And we just heard this here with the Google Oceans. They're correcting the datum.
I can speak to that. I mean, I think the general question was basically like, we're correcting some things. The idea is, I mean, the technicals of what is and isn't correct is the issue. The idea is we can add value when we aggregate things, and then make that useful to other ones. But as to Jennifer's point, I'm not saying every datum in Bath imagery is perfect.
Walked up to me. So we're only working with NGDC on correcting a small data set from the NOAA NGDC archive, but working with them on doing it. All the other data, we rely on our partners to correct it. So Vicky Farini has worked with us closely over the last 4 years to edit all the UNOLS fleet 100-meter high-res synthesis data, and David Samuel, Walter Smith on the low-res, Imbari on insets and that kind of thing. So we're working with the community to do the best job to curate the ocean data.
To close this question, I'd like to give a concrete answer. The sesquicentennial of the HMS Challenger is when you will have that. Be patient.
Okay, thank you.
Any more questions? One more question we're going to take.
Should I read this? Okay, so I'm reading a question that was sent in from Mike McCann at Imbari, and what steps are needed to solve the sociological problems? I think Brian more or less answered that, but we can, if you have any thoughts.
Could you repeat that, Paul?
So what steps are needed to solve the sociological problems?
I would like to take that one because I have a note written up in advance that helps me. I think we have talked about to some extent, and talked about how to some extent technology is going to help us solve some of them, and the progressive retirement of people who are not used to the new ways of doing things and entry of people who adopt new ways of doing things. It's a natural transition. But I think one of the questions that we had in an early version of our slides was, how can we do this faster? How can we encourage the adoption of better ways of doing things? And I had written up a little response for the Schmidt Ocean Institute a few years ago in the same context of how can the Schmidt Ocean Institute encourage data practices that are better and so on. And shortening the list quite a bit given our time constraints, but one thing was share ocean data, which I was very pleased to discover last night in some conversations with Nathan and Captain Hojay? Heiko, thank you. I think that's really coming along very well for the Falcor, and I think for that and the rest of these, there's work that can be done to extend it to wider foundation or foundations that are interested in motivating this change. But establishing community collaborations, which is something that Marcia mentioned, facilitating data analytics and semantics is something that can be done when you have those collaborations and gets into addressing the issues that Matt just raised, and really developing the discipline of oceanographic informatics that Dawn was talking about earlier, and even making it possible to measure those disciplines and the level of informatics we provide. All of these things are very susceptible right now to being motivated, accelerated, improved by the application of a relatively small amount of money from whatever funding organization thinks it's important. And that's what I would advocate for, to move that forward.
So I have my own question now, which is, I don't expect an answer, but I just want to think about it for a second. So data will be available, I'm assuming. And we have many, many places where we see this rich, rich data sets like the Protein Data Bank at Rutgers, where I am. Huge amounts of data come in every day on protein structures and the coordinates of X-rays and so on. Gene bank. We have many, many examples of this. What we don't have is a very good curation of models. So there are model codes that are used all the time to generate papers in the peer-reviewed literature. And many of these codes are privately held and are not released. And so what we essentially have is a journal of irreproducible results. And I'm talking at the highest tier. And unless we break that barrier, I don't think that we're going to have a lot of faith in many of the models, climate change being one, for example. But we could go through many, many other models that are used in our fields about predictions of biogeochemical outcomes, about predictions of ecological change. And unless we have some archive of models and open sourceware that is mandated when you publish a paper, I don't think that we're going to be progressive in this field. That's just my thought.
The thing that I think is interesting about this comment, as well as a number of the other panels before, is that when we've thought about data systems in the past, we've thought about data systems that just manages the data and that's it. And what we're really talking about here is that the data system has to be something that involves the community, the virtual organizations. It has to be better tied to the processing steps in the data. It's a much bigger thing than just holding the data and making the data nicely accessible.
Okay, just one last comment.
The real challenge that you're talking about is how do we archive dynamically changing things? Because models themselves are not static codes. Those models are changed based on different runs. And so therefore, are you really saying that we have to archive the initial conditions for the run, the actual code for the run, and then the resultant data product, the underlying hardware that was specifically used and the software was tuned to run on that hardware, so therefore will not be reproducible 10 years later because you would have to put man-years of work to actually move that software onto a platform that's currently available. These are huge challenges with the class of question you're asking, and it all comes back to we are not yet good at understanding how to archive that which is dynamic.
Thank you so much. So this has been a fantastic panel, clearly supercharged, wonderful discussion. And Peter, is it true that you're willing to forego lunch to stay here to keep answering questions?
Yeah, we're here.
We're here. Woo! Well, okay. Yeah, no. Do you want to have a quick show of hands? Who wants to forego lunch to have a panel discussion?
We'll find out.
Doesn't look like it's going to happen. Sorry, Nat. You're outvoted 125 to 1. So please catch up with the panel members during lunch to continue your dialogue. Let's give them a very warm thank you.